Hello and welcome to this video tutorial. Today we're going to begin our kinetic energy problems. These are fairly straightforward problems as kinetic energy relates to the energy of motion, so all we need is mass and velocity. Now, there might be an instance or there will be an instance where we have to calculate the velocity based on distance and time, okay? But we'll get to that when we get to that. Here we go. The first question we're going to look at is kinetic energy of a ball in a circle. So we're going to get a ball that's traveling in circular motion, okay, and we're going to find its kinetic energy as it's moving. And then the next one, we're going to have a curling stone. Now, if you've never heard of a curling stone, you have kind of like a very, very smooth ice, and you have this block of stone, and you have these people who stand in front of the stone with little brushes, and they kind of smooth out the ice with their brushes. And somebody pushes the stone, and the object is, of course, to get the stone to hit a target and stop at a precise location down the ice. And you'll see it play out in the animation. Okay, so let's go ahead and begin with our first question: kinetic energy of a ball in a circle. Okay, so we're here. First thing we're going to do is we're going to get our information. We're going to draw the ball and the radius in the circle. Write down the number of revolutions that you timed and the amount that you timed it. Okay. All right, so here we go. All right, now, as you can see, we have a ball of mass 427 grams. Please convert that to kilograms. In fact, I would do that on the spot. Okay, grams to kilograms right away. Okay, you can see that my radius, every single box is 0.1 meters. So let's see, my radius is 1 point, kind of halfway between 1.6 and 1.7. So we'll go 1.65. Okay, so now we need to get the time in a circle. We need to get the time that it takes the ball. My ball is here. Okay, and go ahead and complete that same radius all the way throughout. Here, here, here. Okay, so it's going to do that. Now, if you're not happy with your time, like if you don't think that it's adequate enough, um, you can always reset. Okay, but I'm going to go ahead and time it. So to time it, you got to click on the ball. Okay, and we'll go ahead and start the clock. Oh, click on the timer. Okay, so as you can see, I'm not getting a very good, accurate depiction. So what I'm going to do instead is I'm going to have it go for more than one revolution because doing one revolution is hard. So as we did in our centripetal force lab, we timed 10 revolutions as best we could, and then divided by 10 to get the average period or the average time for one revolution. So I'm going to try that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's a little less than that. Okay, it's a little less than that. So I'm gonna go maybe 16.1, 2. Okay, I'm gonna backtrack it a little bit so that my ball is closer to the vertical. Okay, so I'm gonna go about 16.1. Okay, so my time for 10 revolutions, about 16.1 seconds, which means my period would be 1.61 seconds, right? You just move the decimal once to the left. Why? Because you're dividing by 10. Okay, now, how do we get the speed of an object going in a circle? Well, If you remember, speed is distance over time. The distance around the circle is the circumference, 2 pi times the radius. The time once around the circle is the period. We just measured that. Okay, so let's go ahead and calculate. We're going to go 2 pi times your radius minus 1.65 meters divided by whatever your period is. And let's get the speed of your ball going in a circle. Okay, I'm getting about 6.44 meters per second as my speed. Okay, so there's my radius, there's my speed. And then lastly, I just need to calculate, and you show your work down here, it's fine. Lastly, we just need to calculate the kinetic energy. Well, kinetic energy is a very, very easy calculation to do. It's 1/2 times the mass times the velocity squared. Now, the easiest way to run this calculation is square the velocity, do that first. Then multiply by the mass, do that second. Then divide that by 2, okay, to finish it off. Okay, that's the easiest way to run this calculation. So we're going to go 1/2 times your mass minus 0.427 kilograms times your speed minus 6.44 meters per second squared. So put in your information. I just put in mine. Go ahead and calculate your kinetic energy. I'll calculate mine. Okay, now I'm getting about 8.9, and the unit for any kind of energy, mechanical energy that is the joule. Okay, so well, mechanical energy, thermal energy, sound energy, light energy, it's all going to be measured in joules. Okay, so now we're going to go ahead and enter our information in there. Okay, so my radius was 1.65, my speed was 6.44, and my kinetic energy was about 8.9 joules. Okay, there we go. There we go. So as you can see, the first thing you're going to need to do is calculate your radius. Okay. Once you do that, revolve the ball in a circle. I did 10 circles just to make it a little bit easier. If you can be accurate with one circle, then go ahead and be accurate with one circle. Okay. Just depends on how you take the data. Maybe you only have it go twice and divide it by 2, or go 5 revolutions and divide it by 5. You don't necessarily have to do 10. Okay. But once you find the velocity, then it's a pretty easy kinetic energy calculation, 1/2 times the mass times the velocity squared. All right, hopefully you got question number 1 right. If so, on to question 2. Kinetic energy of a curling stone. So in this problem, you must determine the kinetic energy of a curling stone. You will push the stone along the ice, and then you will time it as it moves between the markings on the ice. Based on the time it takes the stone to move a certain distance and the mass of the stone, you're to determine the kinetic energy of the stone. Okay, you can assume no energy loss due to friction during the time the stone is moving between the markings on the ice. That's a pretty good assumption to make. All right, here we go. Okay, so to record, we have to record the mass of the stone, okay, and we're going to record the distance between the timing lines. So you can see the mass of my stone is 15.8 kilograms. Okay, so I'm going to record that. Okay, now I need to make another line at where the starting line is. You can see where the finish line of the curling stone is going to end up, but I got to mark the starting line. And so the starting line for me, you can see, is 24 meters. Okay, there's a blue line at 24 meters. That's where I will start the timer. And I will stop the timer once it reaches 0 meters. So the distance my curling stone is going to move is 24 meters. So I'm going to make a mark right there. Okay, so obviously to find the velocity, this is a constant velocity situation. So that's going to be a very easy distance divided by time scenario. I'll be going 24 meters divided by the time it takes to go from here to here. Okay, so let's go ahead and click on the stone. Again, I'm going to start the timer as soon as, let's see, where's my timer? Okay, timer location. Okay, so if you see in the upper right-hand corner, you have to click to start the timer. So I'm going to reset mine. I've got the same distance. Once you get the curling stone going, okay, then let's see. I'm gonna reset. Okay, so I just reset. I just tapped it, tapped the curling stone, set it back to the beginning. So what I'm going to do is I'm going to tap on the curling stone like I did before, but as soon as the curling stone reaches that first blue line, now mine's at 24. Okay, look at where yours is. Once it reaches there, you're going to click the start timer where it says timer location. Okay, you're going to click on that. Okay. Okay, so it took about 8.24 seconds to move that distance. Which is approximately 2.91 meters per second. Okay, so I've got that. Can I enter so far? Velocity is 2.91. Okay, now I just need to enter my kinetic energy. So from this, I'm going to go ahead and make an easy kinetic energy calculation. One half times the mass minus 15.8 times your velocity minus 2.91. Don't forget to square that. Okay, remember, start with the velocity squared, then multiply times your mass, then hit equals in your calculator, then divide it by 2. Okay, try it in that order and you're never going to mess this up. Okay, and I'm getting almost 67 joules. All right, and there we go. So hopefully you were able to get both of these kinetic energy calculations done. And I hope you see that kinetic energy is truly a very easy calculation to do. If you do have any questions, obviously, please come and see me. All right. Well, see you next time.